Hello everyone. In this video we are going to learn some concepts related to vector algebra. So, to understand vector algebra, it is important to first know about two famous quantities, and these are scalar quantity and vector quantity. If we talk about scalar quantity, then we understand it as a quantity which will have a direction only, but there will be no magnitude. Now we focus on what are direction and magnitude. Basically, direction is a way in which someone is moving forward to. For example, if we are moving straightly, then this means that we are moving in a straight direction. We can also see the scalar quantities in our day-to-day lives. If we look around, then you will see that the clock inside your room is one of the best examples of it. That's because time always moves forward and in some direction. And we watch time by knowing the distance it has covered, whether it's both minute hands and hour hands. Both time has no magnitude. This is due to the fact that time never comes back. Similarly, temperature also has a direction but no magnitude. Now, if we need to know about magnitude, then we can understand it by its English meaning. In simple English, it means a significance or value about any object that is in magnitude. But in mathematics, we understand it by the value of any object. Because if any object moves in some direction, then it creates a significance in its movement. When that object moves at some distance, then. For example, if you go to a kitchen to drink some water and you come back to your place from where you started your distance, then the direction that you covered will have its magnitude, because the distances covered here is in forward as well as backward directions. Similarly, force and acceleration are also good examples which have magnitude along with direction. So according to direction and magnitude, we come to know that scalar quantity only depends upon direction, whereas the vector quantity represents direction along with its magnitude. Therefore, time and temperature are examples of scalar quantity, and displacement, acceleration, and force are examples of vector quantity. In this video, we will move forward with the vector quantity and not scalar. And the symbol that we are going to use here will be represented by a vector. Here the arrow is actually representing the vector and a is denoting a quantity, and we say it a vector. Few seconds ago, we were discussing about magnitude, remember? So if we want to find out the magnitude of this vector, then we will use the symbol mod of a vector. In fact, any vector inside mod represents the magnitude of that particular vector. Now we will understand two concepts. One is dot product and the second one is cross product. These two will be helpful in solving out the vector quantities. Now we will consider two vectors so that we can understand about dot product and cross product easily. So first we will consider dot product. As we can see, there are two vectors in front of our screen, a vector and b vector. So now we will start with the dot product of these two vectors. So for the dot product, we will know two properties related to dot product. The first one is that whenever we come across the terms I cap dot I cap, j cap dot j cap, and k cap dot k cap, then we will assume these as 1. Okay? And the second one is that if we arrive at the term I cap dot j cap, which is equals to j cap dot I cap, and similarly the other two terms, then we will consider this as 0. So now we will find the dot product of a vector and b vector. For this, we will write a vector dot b vector as you can see in front of your screen with a yellow highlighter. So what we are going to do, we will take individual terms of A vector and we will take the dot product with B vector. Okay, so that means we will take 2 I cap and we will take the dot product of this 2 I cap with the B vector. So we get this, and similarly we get the other two terms. So this implies we get 2 I cap dot 6 I cap and similarly the other terms. So after this we get 12 I cap dot I cap and similarly the other terms. Alright, so this part was easy. Now you can see the pink highlighted two properties. With the help of these two properties, we are going to substitute I cap dot I cap equals to 1 and similarly the other terms. So if we get suppose I cap dot j cap, then we will take that as 0. Alright, so as you can see, we get A vector dot B vector, which is equals to 12 into 1 plus 10 into 0 minus 4 into 0, and similarly the other terms. So now we get A vector dot B vector, which is equals to 12 plus 10 minus 2, which is equals to 20. So this is the resultant dot product of A vector dot B vector. Now we are going to move forward with the cross product of these two vectors. So for this, we will write these vectors as A vector cross B vector, and we have simply substituted A vector and B vector into the places. Okay. So what we are going to do, we will put the coefficients of I cap, j cap, k cap into the modulus like so. So first we have written I cap, j cap and k cap in the first row. After this, in the second row, we have kept the coefficients of A vector, and after this we kept the coefficients of B vector. So let's start with the cross product. We can see that if we consider I cap, then we will ignore the horizontal and vertical line of I cap only. I repeat, we will ignore only the vertical and horizontal lines of I cap, and the remaining numbers will be 2, 1, 5, minus 2. So what we are going to do, we will multiply 2 and minus 2 with each other and 5 and 1 with each other, and we will subtract 2 into minus 2 and 5 into 1. Numerically we can write it as this: A vector cross B vector, which is equals to I cap, and we have multiplied 2 and minus 2 and we have subtracted 5 into 1. Similarly, we will do this with the other terms also, j cap and k cap. As we can see, as we have taken j cap, so we have ignored vertical and horizontal line of j cap only, and we were left with 2, minus 2, 6 and 1. So we will cross multiply this as like so. If we see it carefully, then we have taken minus j instead of plus j, because this is a part of the rule of cross product, that whenever we consider j cap or the middle xyz, then we will take that as minus sign. Okay. Now similarly with the k cap, we will cross multiply this as this. Okay. So after solving it, we get a a vector cross b vector, which is equals to I cap, and we have just simplified the terms. So at last we are going to get A vector cross B vector, which is equals to minus 9 I cap plus 10 j cap minus 2 k cap. Okay. I hope you have understood the dot product and cross product of any two vectors. I hope you like this video. More conceptual videos are on the way, so please like, share and subscribe to my channel, And if you have any doubts related to this video, then you can write that down in the comment box below. Or if you want to know about different topics, then also you can write that in the comment box. Thank you.